I'm John Heinz. This is an Augtera session talking about probes and flows, multi-cloud performance insights. And we're going to go through a couple of scenarios and some live demos as well. So a quick overview, right, is you think about the digital organization today. They either have all or a subset of this type of network. You have SD-WAN, you have cloud, you have your private data centers, you have your direct connects, WAN carrier POPs. And so the challenge is, and we were just at ONUG last week, is observability to this hybrid multi-cloud domain. How in the heck do you do it? Because each of these things has a different type of telemetry. My SD-WAN provider may be proprietary. I also have flow logs in the cloud. I have, my Equinix data center, right? I also have my own data center. So how do I understand where the problem's at in my network? And this is the thing that Augtera can solve, because we can collect data from this multi-cloud network. We also have our own probe data you can put in the network to really understand where the issue's at, who's experiencing pain, and what application it's affecting. So that's kind of the genesis of this session. And I thought we'd start with an example. And there's actually one a couple today, maybe or yesterday, that we caught too, which is interesting. Is Amazon had a bad December 2021. They had a couple of really big outages. And if you're an Amazon user, you're affected in different ways. So what we have is at Augtera, we have our software deployed across multiple clouds. I'm going to show you a live example of that in a second. What it can do is we see now intra-cloud and inter-cloud performance. So if Amazon West has a problem with Amazon East 1 or 2 or whatever it is, we can see that. So in the case is we were sitting at our office in Palo Alto. I got this anomaly coming in saying, man, it's a bunch of stuff going on Amazon. And I saw it in the news, right, that there was an outage. So the cool thing here is, we saw this, our anomaly detection saw us well before Amazon posted about it. So if you were using our software, you knew there was an issue before versus hitting refresh on that Amazon, status page. Not to pick on Amazon. But what's also interesting too is this lower right-hand side is that depending on where you had to compute at, you were affected differently. So if you're running stuff in East and West, you might have been affected at all because those sites didn't experience any issues. If you had stuff in Azure talking to AWS, you were very much experienced. They were like 100% drop. So depending on where your customer accessed your data from, their experience might have been different than how you saw your data. So it's an example of how to use this technology to understand your cloud performance. What we do is we actually make this available on our website. So I'll show you is at Augtera.com, we have a thing called Live Multi-Cloud Anomalies. And we put this out there for everybody to get. We think it's a pretty cool thing. You will see in real time how the multi-cloud is performing. And we have at the top, we have persistent degradation. So we're actually showing you that, if you click this past anomalies, that there's been several issues between US East 1C and GCP US 1B.
And this is just available, so people can.
It's available. Yeah, we're just nice. So we're looking at two things, right? We have real-time performance degradation, so just round trip time, and we have persistent loss. And so these are showing you now that that you had almost no loss, but now 50% loss is a pretty bad thing, and it's sustained, which is actually more important. To me, sustained equals actionable. If it's a blip, okay, it fixes itself. I can't do much about that. But if it's going 20 minutes, 30 minutes, 40 minutes, now I need to take some action. Maybe I have applications, high availability, I can reroute things. But these are examples of these happening. You can see there's always some kind of entropy in the system. You can kind of see it over time. You can do it in your own time too, as you want to mess around with this. But we also see lots of patterns, like in this case where Azure West US had several issues to multiple sites in UAE, Australia, Northeast. So there's lots of times there's correlation between these outages that maybe just people aren't aware of. That's an example of how we use Augtera probes deployed across the cloud. You could deploy them in your campus, your branch, your data center to see how your performance is in real time. And as you scroll down, you'll kind of see again these correlation, right? Where like Jim was mentioning, this is looking at, all right, of all the noise out there, what's my worst ones right now? In a correlation, you can see for round trip time is between US East 1C and US and GCP 1B. This represents the noise, the actual raw data for round trip time that's too hard for a human to consume and understand. You need a machine to tell you when to actually focus on something. But we put it here because it is kind of interesting to show that. Here you kind of see noise standing out, right? This is the most sites having loss right now. So that's kind of an example of how we're using probes to find issues in multi-cloud and hybrid cloud. The next thing I'll do is show another example of using this same kind of thing, but for flow logs. We showed you S-Flow already, so you've seen that in previous demo. What about on the cloud side? How can I use Cloudflow to detect issues with applications? The first example is this. Someone I figured mentioned infrastructure as code happens all the time. Someone misconfigures an ACL or a rule, and suddenly you have something happen that you didn't expect it. Happens all the time. This is how we detect it. So in this scenario, they're doing code deployment. Someone misconfigures a rule. It actually breaks an application. Augtera sees a spike in rejected flows. So in AWS, it'll tell you if a flow is accepted or rejected. We expect some flows to be rejected in general because of the nature of security groups and people trying to do stuff, applications trying to talk, but we don't expect big spikes. And that's something we're going to go investigate. So in this demo, that's what we're doing. And I'll show you it live as well. So what happens first is, our lovely Slack, we get a notification saying that you have an increase in VPC rejects. This is the kind of the view of that in my Slack notification. I go to the link in the anomaly and it goes right to that page. This is the time series that we're looking at initially. I can adjust this here, look at maybe 6 hours, an hour, whatever. So now we're seeing, yep, there's always some, but not this much. Now, same kind of thing. I did go figure out, okay, what's being blocked? Is this important to me or not? So I go from an anomaly to an analytics view. And the same thing here we talked about earlier is now I need to go and populate dimensions or give it some substance to the data. So in this case, I want to see, again, source IP, source port. And you're kind of seeing how fast this works in real time. It's pretty, it's pretty impressive, I think. But you can see that as I add these things, it's going to start showing up very, very quickly here. And now in this case, I want to look at this by out packets, which I'll do. And now I'm going to see all this data to the right sorted by out packets. So what do I see right away? I see, all right, I have a common source IP. I have a common source port. Look at my destination ports, destination IP address. They're at 1433, 1434, related to SQL Server. So someone broke SQL Server doing this code update. Augtera saw it as an anomaly. We produced the incident, right? And now with some context, they can go, all right, these are the applications impacted. And again, you can use things like AWS tags to give you more context, like, oh, application name, application owner, things like that.
Yeah, so, you rattled off some port numbers and you're like, oh yeah, that's Oracle, because you know that. But I mean, if these things are so well known, then could they not be just part of Augtera that says, hey, this is an Oracle problem?
Yeah,
it's like one little hop step. I'm not asking again for science fiction to give us, true root cause, or dare I say AI. But I mean, those things are kind of a little obvious. Like, it's like, this is a SQL Server problem. This is a blah, blah, blah problem. Rather than somebody have to spend like one more,
look up a port.
I mean, we all do it. Again, I'm thinking of, the workflow of I've got, a layer one NOC team who is smart. They're not just, follow a script kind of people, but they're not going to know little nuances like that, perhaps.
Yeah, this actually we can do. This is pretty straightforward. There are many ways to you can say label an anomaly, and you can just teach the machine. You can label the anomaly in many ways in our software.
Yeah, I mean, going back, again, a little science fiction-y, but going back to the fact that you have specific models for specific things like environmental, like fans, power supplies, tying into the weather of the area where that thing is to see like, oh, there's a heat wave going on, or there's a heat wave coming. These are things like
context is important.
Yeah, I mean, that context actually does play into a lot of the rhythm of the business I'm in. So, I'm interested in that.
Yeah, so I think two different points, right? I think you're asking for two things. Both are very important. One is when you produce an anomaly, can you actually, because in this particular case, it's these are some well-known issues. Can you actually label an anomaly with, call it root cause? We in fact have a dimension called root cause. But we need some operator feedback for that. You can do that feedback as a classifier. You can do it when you create views in our software to mine the anomalies, or you can do it as feedback which you explicitly give to an anomaly. It makes the machine learn. That's one thing. Second thing that you're asking is, you've got this highly contextual metadata, which is really relevant to your business. Whether it's temperature or audience in a game, whatever. That metadata comes back to what Bhupesh earlier talked about. you can give that to us using our API. And then that becomes part of metadata, which you can do anomaly detection on. You can choose to ignore certain things, add certain things, all of that.
So to bring this back, when we were talking about the SSH brute force, conditions, I think was the word. So you were just talking about like you can provide this feedback and it will actually learn that. So is this something where kind of those conditional scenarios, when we see this, I as an operator have said, well, this is what happens, and it's essentially learning that when this happens, this is what we called it, and then the next time we see that criteria, we know that this is what it is, and now we're not. It's not determining on its own that it's what it is, but it's saying, hey, we saw this before. You said it was this. We're seeing it again. This is what it is.
Absolutely.
Cool.
That's exactly right.
Training it, yeah.
Yeah.
I got one more 1 week demo we can do. So that last example was an example of an aggregate object. What I mean is we're not looking at an instance in Amazon, we're looking at the whole VPC. Because things are ephemeral inside the cloud. And so maybe, an instance level is just too detailed because instances come and go. But at the VPC level, or at the account level, or at the region level, you can define that ad hoc, call them aggregate objects. So what's important is, you can figure out what's important in your cloud environment you'll be notified on. This next example is very detailed. It's as detailed as you can get, right? It's actually, we're saying that we have an application that's hosted. We have these occasional user reported issues. We don't know what's going on. We haven't quite figured out what the cause is. But now we have Augtera, and so the world's gonna be great. We put an ML on VPC flow logs, and what we do is we're actually looking at the TCP session metrics per instance. And so what happens is when an instance has an unusual condition with TCP, with a certain TCP flag or multiple flags, it's detected by our ML. And so now the operator can quickly see if these issues reported by my customer align with these Augtera anomalies. Or in better world, right, is we would detect this proactively before a customer calls us. So it's a similar thing. I won't run with the full workflow because you kind of get the idea, I believe. But the point here is that it's looking at flags. We get the notification. In this case, it's like the RST flag. So what Augtera can do is look at every flag at the device level or instance level, even at the ENI level, at the interface level, and tell you the historical pattern and when that pattern deviates. And again, this is the anomaly. I would say, yeah, why do I have so many RST packets going to this device? I can see my instance ID up here as well as my NIC. I may want to go to trends and do more deep dive analysis. In this case, because I think it's an attack, I really want to see like source IP, for example. And so that might be the dimension I add in this view is like source IP. And you get the idea that we've talked about before is I can add these dimensions ad hoc. We have a lot more dimensions for AWS and Google that I could show you, but in sense of time, there's no point just going through them verbatim. But it allows the customer, the person to see exactly who is initiating this attack, this 184 IP address, and put a security group rule in place to block it, or understand that. Or maybe it aligns with the things I'm seeing like in probe loss. If this device is running a probe as well, I could correlate probe loss with an attack happening to see now I know for sure it's actually affecting my user, for example. That's really it. A couple examples of multi-cloud. Kind of going back to the slide. You think about getting visibility across all your domains, combination of the telemetries, and we can adjust all that. These are examples of flow logs in this example in probes.
Do you have any examples of like customer success stories? So something that's been fed back, maybe they actually have spotted an attack and managed to block it.
Oh yeah, I think you can speak to that.
So I think we've got our deployments across. So we've got very large scale deployments in Fortune 500, data center environments, and as well as in SD-WAN cloud. So on the customer story side, we've got this, very large retailer, e-commerce company, data center WAN environment. And since they've deployed the product, their, mean time to detection has dropped almost by 90-some%, like from 40-some minutes to 1 minute. And the time between incidents as in revenue impacting incidents has gone up by 4 times. Right. Then we have another one worth pointing out is Orange, which I can name publicly. The first one I can't name publicly. In their case, we are finding about 50% issues which are not being found by the current software, the current tools that they've been using. We've got a very large SD-WAN deployment as well. We can share customer stories around that. What's relevant to what John was just talking about, hybrid cloud, we've got a large financial, which is finding a whole bunch of issues around. There have been cases where they've detected, for example, TCP SYN anomalies, and that was because of an attack.